welcome back to the third session of the chapter Carbon and its Compounds here at your favorite learning app Vidwath Academics. By the way, I am your Asha Naik science tutor. So, in this session, we are going to discuss about properties of covalent compounds. We got to know about everything about in detail about the covalent compounds, right? That is covalent bond. Carbon to alternate stability by covalent bond, that is by sharing its electron, that it leads to peaceful, that is that carbon atom is like I won't lend electron or I won't borrow electron, so that it doesn't lead to tension. So let me be in the peace by sharing electron, that is by forming covalent bond. So let's see about the the compounds formed by covalent bond. What are the properties of that covalent compounds? Clear? So that is nature of covalent compounds or properties of covalent compounds. The very first thing is covalent compounds have low melting and boiling point, because we do know that covalent compared to ionic bonds, we do know that ionic bonds like for example NaCl, which is formed by the bond is formed between the two opposite charged ions, right? So as it is, the force of attraction between these two ions will be more. So the molecular force, okay, the bond, force is higher in the ionic bond. So it requires so much of energy to break the bond. Whereas the covalent compounds, like if you take it as a CH4, here you don't need to supply so much of energy, because the force of attraction between the atoms is less. So the force of attraction, the molecular force is less in the covalent compounds. So covalent compounds have low melting and boiling points, that is it absorbs less energy comparative to ionic bonds. Clear? It's all because of the molecular force, the force of attraction of the compound. Covalent compounds do have a less force of attraction, whereas ionic bonds do have a more force of attraction. Clear? So that's the reason covalent compounds have low melting point and low boiling point. Clear? So the next property is covalent compounds are generally poor conductors of electricity. We do know that electricity is nothing but flow of electrons. So to conduct electricity, there should be ions, right? Whereas NaCl, we do have a Na plus, they do ionize into ions as Na plus and Cl minus. Whereas because the bond is formed by the cation and anion. Whereas this covalent compounds, it is not formed by ions, right? So it doesn't dissociate ions. So for that reason, they are poor conductors of electricity. Covalent compounds won't dissociate its ions, as it doesn't formed by formation of ions, whereas ionic compounds are formed by the bond is formed by between the ions, whereas covalent compounds, they are not formed by ions, right? The bond is not formed between the ions. So the covalent compounds doesn't dissociate ions. So as that result, they are poor conductors of electricity. Clear? Covalent compounds are poor conductors of electricity because they don't give ions. They don't dissociate ions. Clear? No ions, no electricity. Covalent bonds is not formed by the ions. So no ions, it doesn't dissociate ions and it doesn't conduct electricity. Generally, they are poor conductors of electricity. Covalent compounds. Clear? So the next thing is, the next property is covalent compounds have strong force of attraction within the molecule, but the intermolecular forces are very small. If you consider example H2O, okay, we know that hydrogen requires one, it satisfies its valency by forming single covalent bond, whereas oxygen, it needs two, right? It is a double covalent bond, so it forms a double covalent bond. So if you can see here, the force of attraction here will be more. That is here. The covalent compounds have strong force of attraction within the molecule. Okay, it is usually called as intramolecular force. What is intramolecular force? That is the force within the molecule, inside. Okay, Whereas if you can see here, inside a water we do have so many molecules, water molecules, right? So here this, clear? So this force of attraction between the two molecules is known as intermolecular. Okay, intramolecular is more, that is the force within the molecule, the force of attraction within the molecule, that is intramolecular force is strong, but the intermolecular, that is between two molecules will be small, that is intermolecular. Okay, intermolecular force means the force of attraction between the two molecules. Intramolecular means the force of attraction in the molecule itself. Okay, in the molecule, intramolecular force is more than the intermolecular force of attraction. That is the force of attraction within the molecule is stronger than the force of attraction between the two molecules. Clear everybody? That is what intramolecular and intermolecular. Clear? So that is covalent compounds have strong force of attraction within the molecule, that is intramolecular. Intramolecular force is stronger, but the intermolecular, that is force of attraction between the two molecules, are very small. Clear about this point? Yes, the next property is covalent compounds are generally volatile in nature. What do you mean by volatile? Volatile is nothing but which can escape easily, which can evaporate easily, because we do know that covalent compounds, the force of the molecular forces, the force of attraction in the molecule is very means less. Okay, the molecular force is less. Clear? So that's the reason the bonds can break easily and it can evaporate easily. That is, covalent compounds are generally volatile in nature, that the bonds can break and can evaporate easily. Okay, as the bonds are weak in covalent compounds. Clear? That's all for today. So I hope I made the concepts very clear. So to watch few more interesting sessions like this and to have a better learning experience with us, do subscribe Vidwath app, and guess what? We are in the following social media. Go there and follow us and get all the updates of Vidwath. At last, to be the best, always choose Vidwath. Until the next session, keep sharing, keep subscribing and keep following us. Thank you.